So, welcome to my dear students. Basically, this lecture series is for a group of my students, Rahul and his team, who are working to design a system uh, which is basically for defense application, that where the army or the defense person people are suppose they are in a remote area where the signal is poor. So what is the basic scheme? That using a drone and antenna, it will be taken up in certain elevation, and the signal will be captured, and that will be transmitted through some coaxial cable in the bottom, and then it will be distributed to several local stations, and the signal strength can be um, increased. Okay, so this basically, even though I am extensively working in nuclear science as a nuclear scientist, but still basically I am a communication engineer, and I worked extensively in communication system in several several uh, places. Like in my college days, I used to work in Calcutta Metro Rail. They are in communication system. It's a very interesting subject. People who are strong in mathematics, they can only go in depth of this communication system. Again, I am telling, it's my very favorite subject, and even though due to my present responsibility, I am detached from it for last around 20 years, but still I like it. Whenever I get the opportunity, I'll not miss to involve myself in that. So there are so many equipment. We will be in that project, we will be using so many equipments. So here I will explain the design part one by one, even though I'm not going to in depth of it, but I'll give you the glimpse how to quickly design it. So the first and important part is the antenna. Antenna is a very important gadget in communication system, which is a device that used to transmit and receive electromagnetic signal, such as radio waves. uh, its main function is to convert electrical signal into electromagnetic waves and vice versa. While you are transmitting a signal, then it will going to antenna end, and from there the electromagnetic wave is generated and propagated. And when you are receiving the signal, so electromagnetic wave, it will be captured by the antenna, antenna dipole, or whatever you may say, that will understand later, and then it will be converted to electrical signal. Further, it will be post process, and it will be coming to receiving device. So this is basically basic function of an antenna. So as I spelled the electromagnetic wave, so what is it basically? Basically, those are created by the oscillation of electric and magnetic field that are perpendicular to each other. In our basic electromagnetics, we know that those are normally, it will be in perpendicular, they're aparted perpendicularly, okay, perpendicularly. And this electromagnetic wave can travel without any medium, and the main advantage is that can travel at the speed of light. So in communication system, the speed of propagation is a very important factor, and as it's propagating at speed of light, so it will be very advantageous. Okay, now whenever now how to generate, how antenna, and before going to the design of that, today we will discuss about the design of log periodic dipole antenna array. Prior to design, or going to design, let us understand the physics. Very simply, let us understand the physics behind it. Okay, So normally, what we understood that an antenna will generate the electromagnetic wave from the electrical signal and vice versa. Now, whenever this electromagnetic concept of electromagnetic wave, it's coming immediately. Our mind is coming that our nowadays induction cooktop. There, what is happening? There is a coil, and in the coil, we are giving very high frequency pulsating electrical voltage or current that will produce in turn varying magnetic field, and that varying magnetic field, it is if you keep any ferromagnetic material cooking utensils, so there it will create eddy current that will create the heat, and using that the food will be cooked. It's very simple, but here the problem is, in this you see, this is the coil of a m- this induction heater. Okay, but the problem is here, the whatever the electromagnetic wave it is generating, that will not coming out from the source, from the coil. It will be moving surrounding of it. But in case of antenna, we need to, that whatever the electromagnetic wave it will be generating, that should come out from the antenna and it should propagate. Then how to do it? Coming to very I'm going to our uh, basic science in class. You can remember your class 8th or ninth. So if there is some charge, positive and negative charge, that those are aparted with some distance, which is created, which is basically called the dipole, then the electric field distribution, it will be like this. Okay, this is the electric field distribution, and obviously magnetic field, it will be perpendicular with that. So this will be like this. It's a very simple concept, and all we know that. Now I am coming to some analogy. Let us say this is the case one. This dipole, this charges are kept at some distance. Then the field line, the electric field line will be like this. Now let us slightly reduce the length of the dipole. So what will happen? So your field line, it will be changed like this, and if you further reduce it, the shape will be going like this, is shown in the picture. And once the dipole length becomes zero, because the means the positive and the negative charges are coincide each other, then the line, they join together. Okay, and it's become a closed field line. And then further, if you extend, means the polarity is getting changed, then what will happen? Then the electric field that will be separated from the source, that means from the dipole, and it start to propagate. This is basically need for the antenna. If you see, if the dipole, if you can create a dipole which can continuously, which can changing its length by somehow, then this will create the uh, electromagnetic wave which can propagate at the speed of life in space, or even though without the medium also. This varying electric field is also in the fashion, the variation, it will be in some sinusoidal manner, and the wavelength, the wavelength, the wavelength of the that generated electromagnetic wave basically is 2 times of the length of the dipole. It can be proven very easily. Okay, so this is basically the fundamental of the fundamental theory, or the physics behind antenna. Now let us consider one with that analogy, whatever we understand in this slide. Let us now take one setup. Say this is one varying electrical source, electrical signal, and there are two conductors are like this, connected like this. So due to the, say, at certain instant, this polarity of this end is positive and this end is negative. Okay. Now as it's a time varying signal, so after the next instant, this will be, after some time, this will be minus and this will be plus. So that you can draw the inference what is happening in the I told about in the previous slide, that polarity is keep on getting altered in antenna with some very high frequency. So now if you take this device here, so based on the signal, electrical signal, this dipole slowly it will, the length of dipole it will reduce, then it is coincide, and then it is slowly the polarity is getting opposite, and the same thing it is getting repeated. Okay. And so the uh, uh, whatever we need to generate the electromagnetic wave, that can be achieved with this setup. This is basically a and simple dipole antenna. Okay. And mathematically it can be means, or pictorially also it can be proven that the length the length of the dipole should be half of the length of the half of the wavelength. So the each segment here it will be, so if the total, the wavelength, electromagnetic wavelength is lambda, so I'll go to the, where is that slide? Okay, that I will. So if the electromagnetic wave length, so here say this is, if this is the lambda, this is the called wavelength, this is the, if this is lambda, then this segment should be lambda by 4 and this segment should be lambda by 4. Okay. Now I am giving one uh, typical example to design the LPDA antenna. Okay. So the first thing is where you are first you have to because I am giving you the practical approach how to go ahead. So there is a app available in the net Play Store, which is called Net Monster. If you open that, then it will give all the if you install that app in your Android device, it will give all the available signal in a particular place. So from there you have to select the frequency range. Why I am telling this, what are the signal available in the air right now where you are staying? First we have to know about that. So here I am taking a typical example, say in my place where I am right now. So say the signal I have seen from that app Net Monster, that the signal is varying from 800 megahertz to 2.7 giga means 2700 megahertz. So I'm keeping some margin 50 megahertz. So let us design one LPDA antenna which can able to receive and transmit the signal in the frequency range of 750 megahertz to 2750 megahertz. I'm keeping slight margin. So as I told, the v, the velocity is equal to, we know, that is nu lambda, correct? So my lambda is equal to v by nu, that means the frequency. So the as I told, the electromagnetic wave is propagating at the speed of light. So this is the speed of light in centimeter per second, and divided by 750 mega, which is 40 centimeter, and the lambda max. Sorry, this will be lambda max. This will be lambda max, and this will be lambda mean. So this will be similarly that velocity of light divided by the frequency. In such case, sorry, I did mistake. So it will be 2750. So whatever the figure it will come, it will be like this. Okay. Now you see, if this length is lambda by 2, then only the situation when when the particular electromagnetic will be incidented on the antenna. So see, here it will be positive, and here it is negative. And in some instant, in the some other case, so when it will be the things, it will be just opposite to that. Say it will be like this. It will be, sorry, it will be like this. So here it will be positive, and here it will be negative. So exactly the length of the dipole should be the half of the wavelength of our interest. Okay. So you can take an example, that particular example. Say this is my maximum uh, wavelength, and this is my minimum wavelength. So my if I design that log periodic dipole array, antenna array, then the maximum length of the dipole should be half of that, because I need the this things lambda by 2, so 20, and it is about at about 5.6. Okay. So now, how many like that dipole should be there in that antenna? That we should predict. We should calculate. So here we should again, it is lambda max by lambda mean or something. It will be there. So in that particular example, so this will be 40 by 11.1, which is 3.6. Now the scaling factor, how it will be getting reduced. So the length of the dipole, how it will be, in what fashion, in what factor it will reduce, so that for that it will that value will vary from zero point 0.8 to 0.95. So in my in this design I have taken, and I can remember in my first I have designed one antenna during my college days. I think that is in the year of 2001 or 2002, in my college department lab, and it was, I tested it also, this LPDA. That is, I was that time very happy that whatever we learned, that is getting reflected in our practical work, and uh, receiving the, and I can see that it is producing the desired output. I was so happy. So always I will insist my student that academics should be perfectly reflected on practical output, in a form of practical output. So that's why I am telling all of my students, don't treat the academics only inside the pen and paper. You implement it, then only the society will be benefited. So in this design, I am considering the scaling factor is 0.1 0.9. So my number of element, it will be log 3.6, this 3.6 divided by 1 by that scaling factor, which is around 12.15. So I will use, so here the 13 elements it will be there, 13 dipoles it will be there. Another is called the spacing factor, the how much space it will be there in between two consecutive dipole. So that also, it will typically, it will vary from 0.05 to zero point 0.2. So in my case I taken 0.1. So this these things it will be multiplied by zero point 0.9, then 20 into zero point 0.9, because that is my scaling factor. So 20 into zero point 0.9, 18, then 18 into zero point 0.9, 16.2, then 16.2 into zero point 0.9 is 14.58, then 14.58 into zero point 0.9 is this one. Now the space between these two, so this will be scaling factor is 0.1. So 20 into zero point 0.1 means 2 centimeter. 18 into zero point 0.1, 1.8. So this distance is 2. This distance is 1.8. This distance is 16.2, and so on. Okay. So now if you see the total length of the antenna, this, it will be around 15 centimeter. It's a very simple thing, and finally we will design it, we will test it, we will see all these things in our own eyes, whatever we will be learning. Okay. Now the connection, how to basically implement it. So this is a insulator or non-conductor, and this length, as we already understood, so this length it will be lambda by 4, and this length also it will be lambda by 4. So this will be 10, in first case 10, 10, then 9, 9, then 16.2 half, 8.1, 8.1, then it is 14.6, then it is 7.3, 7.3, like that going. And now coming to the connection, this will be zigzag connection. So this red color you can consider it's a positive lead. So here positive one, it will be connected here, then in next here, then in next here. In that way it will be getting connected, and finally once the waves it will be uh, incidenting here, you can receive the equivalent electrical signal at the output. And then that output it will be you have to amplify, you have to eliminate the noise, and then it will be taking to the receiving device. That we will learn one by one. And this arrangement, if you see in the market, so uh, these are the available, this LPDA. Now inside the enclosure, the same thing whatever we have discussed, it is enclosed there for outdoor application, because small electronics also it will be there to after receiving the electromagnetic wave, when it is converting to electrical signal, that is to be immediately at the receiving end itself. You need to amplify and enhance the signal quality. So for that some small electronics it will be there, but this antenna it will be normally installed and outside. So from the environmental ingress, this enclosure is made. Okay. So hope I am able to give you the glimpse of uh, how the antenna works, and how to very fundamental design of a log periodic dipole antenna array, which we are going to use in our particular project. So thank you so much. You please watch this, and in case of any doubt, you can always ping me, and we'll continue the lecture series and implement the system, and we'll capture the video, and the same thing also I will share to you. Once again, thank you so much. Thanks for your patience.